Okay, this is a video to help you with arc length and sector area. Arc length is the portion of a circle or a portion of its circumference, essentially the red line on this sort of Pac-Man shaped figure down below here. The sector is the portion of the area's circle, so we're missing this portion over here, but the blue area is essentially the sector area. The arc length is just S equals R theta. It's a fairly simple formula for finding arc length, or taking that red line, if you could stretch it straight and flat and then measure its length, you'd be measuring the distance around that red arc. Sector area, A equals 1/2 R squared theta. Theta for both of these formulas, here and here, has to be in radians. But it's actually, again, two formulas you're fairly familiar with. If you plug in 2 pi for radians, it's essentially going all the way around the circle. R times theta, well, R times 2 pi essentially becomes your circumference formula for an entire circle. And the same thing happens. 1/2 times 2 pi is essentially just pi, and pi r squared would be the area for, again, the entire circle. What we're going to talk about are only portions of circles, so just sectors and arc length, not necessarily going one entire circle, or possibly going multiple circles, not just going a single circle. First thing we need to figure out is, notice that our 105 degrees right now is not inside of our sector. So we need to take that 105 and figure out what our angle is, or what we call the central angle. Well, 360 degrees minus that 105 degrees leaves us at 255 degrees. And if we take our 255 and convert that very quickly using our pi over 180 degree conversion, well, 255 divided by 180 essentially comes out to 17/12. And of course, don't forget the pi. So now we can go down and use our formula to find sector area, or sorry, find arc length first. Arc length, again, is radius times radians. So radius of our circle, 12 feet, times radians, our central angle of 17 pi over 12. Nice part is we've got a 12 on the outside, 12 on the bottom. And so if we can find 17 pi, or 53.407 feet, we have our arc length. The area formula works the same way. 1/2 r squared this time, so again our 12-foot radius right now, squared, times 17 pi over 12. You can reduce it down a little bit, you can pop the whole thing in the calculator, whatever works for you, but you should end up with 320.442 feet squared. And there is our area. Now we can use these in various ways. One good example is a windshield wiper. Realize that a windshield wiper, however, though it does clear out a good area, notice is missing sort of this bottom portion. So if we kind of filled in this little part here, we will be missing that red portion. So John's car is covered in mud. If he turns on the wiper blades, again, it clears out this white portion on there. It's traveling 130 degrees each swipe. 3 feet at the farthest distance, so again to pivot point, that's 3, but the actual wiper blade, or this direction, is only 2.5, and as long as we're at it, we may as well fill in that remains, that leaves an extra 0.5 then, down below there. And I'm going to kind of place that on a different spot, just so we don't get confused. 0.5, again, is this portion. Well, what's the area the wiper actually cleans with each swipe? Well, if we take the entire sector, the white plus the red, and we subtract away the red, that should be one way to find just the white portion, just what it's cleaned off. So again, area formula is 1/2 times the radius, well, from pivot point all the way to the end, the radius right now is 3 squared, times, now 130 degrees is not in radians, so we need to say 130 times, again, pi over 180. And again, 130 over 180 is 13 pi over 18. Now we can take that portion and subtract off the red part. So 1/2 radius 0.5 squared times again radians. And notice again, it doesn't matter that it's a smaller portion, it's still traveling through the same central angle. If you type all that very carefully into your calculator, you should end up with 9.927 feet squared. It's a good example of a sector area problem. In fact, a double sector area problem where we have to subtract away. For another helpful question, thinking again about that wiper blade, what if a mosquito were attached to the end of the blade up here? And it's going to be traveling around that edge, back and forth. How far would it travel on each swipe? Well, remember, it's just radius. For that edge, we're traveling at a 3-foot radius. And on each swipe, again, still 130 degrees, or 13 pi over 18 for a central angle. And your answer for that problem should be approximately 6.807 feet. So fairly straightforward there. Again, that's a good example of arc length. Now, one last one for you, and this one's actually pretty much straight out of the book. You're having dinner at the Space Needle restaurant. Realize the Space Needle restaurant travels in a circle, so it has a diameter of 94.5 feet, but makes one full rotation every hour. Dinner is going to run, or we're going to be at dinner between these times. And assuming you're sitting 2 feet from the exterior window, of course you're not sitting right on the window, approximately how far would you travel while eating dinner? Well, that's an arc length problem. We're traveling around that arc of our circle. S is going to be equal to the radius times, again, the radians. Problem right now is our radius is a diameter, and our radians are mixed into this rate. Rotations are just an angle, so an angular speed, and we know a time. The beauty is, remember, any rate times time essentially will give you distance, or for us right now, the angle. So we can fill in the parts. First of all, half of 94.5 is going to be 47.25 feet. But then remember, we need to subtract 2 because we're sitting 2 feet in from the window. So our radius is going to be 45.25. So we're going to say S equals 45.25 times the rate of the angle. Well, it's 1 full rotation per hour. 1 full rotation, remember, in radians is 2 pi radians per hour then. And remember that this over here was in feet. Well, if we take that times the number of hours, we should be able to cancel down to feet times radians. And remember, if we don't label our radians, we should be just a label of feet, how far we've traveled. Well, 642 to 818 is an hour and 36 minutes, and 36 over 60 is essentially 6/10, or 1.6 total hours. So we're just going to plug in 1.6 hours here. Again, now it just becomes a matter of popping that in the calculator. Realize that, again, the hours are going to cancel. The only label you're left with is feet, and you should end up with approximately 454.903 feet. A fair amount of distance to travel while you're just sitting eating dinner. Have a great night. I hope this video helps you out. And if you have any questions, make sure you see your teacher.